right, this is Algebra 1. This is 4D number 2, and this is a little late in coming, but if you are stuck or you haven't got this far, maybe this will help you. What you're going to do here, the rules just say distribute. So remember, when a number or anything is written right beside parentheses, it's wanting you to multiply. So it's wanting you to take 5 times everything inside these parentheses. So you're going to take 5 times 3a. Well, 5 times 3 is 15, so you've got 15a, okay? Now, this isn't any old 9. You could think about this as a -9 or a -9. But when you take 5 times a -9, remember, a positive times a negative is a negative, and 5 times 9 is 45. Some people just like to think, well, I got a minus sign there, then I got a minus sign here, and that's good, except for later when we do have to distribute in a minus sign. Living, I'm told, real still. Okay. Now we're going to take this 5 times this 2a. It's a positive 2. Well, 5 times 2 is a positive 10a. And this is your answer right here. That's all there is to it right there, and you're done. All right, let's go to 4e. This is number 1. And I saw this one that you're going to have to distribute in a -2. So I thought, you know what, we better look at this. When you distribute in a negative, it's a little tricky. So you got to be really careful, because what's going to happen when you multiply this -2 inside, anytime you multiply it by a negative, it's going to end up changing all these signs. Kind of watch how that happens. Remember, if you don't see a number right here, it's like there's a 1 even though you don't see it. So think about this. -2 times 1 is -2. So you're going to get a -2q. Okay? Then we're going to take a -2 times a positive 2. Well, negative times a positive is -4r. Okay? Notice it was positive, and once I distributed this in, it changed it. See how the signs change? That's why I'm like, it's tricky. Be careful. Okay, then we're going to take -2 times, not a 3. We're going to take a -2 times a -3. We'll think a negative times a negative is a positive, and 2 times 3 is 6. So you're going to get 6e, and that's your answer right there. So just be real careful. All right, now I also want to look at number, I'm looking real quick here which one I wanted to look at. Number 6. This is still from 4e, so let me write this out real quick. What they're wanting you to do right here is find the greatest common factor. You're going to have to look at all of these and find something that will go into all 3 of these values. What will go into 20, 40, and 100? So at first I was like, ooh, I guess it is. I was thinking 10, but good grief. Won't 20 go into everything on all 3 sides? So they're going to want you to factor out a 20. So we're going to take a 20, and we're going to do the opposite of the distribution property. I'm thinking 20 times what value would give me 20a? Well, hopefully you can see that 20 times a is 20a. Minus 20 times what would give you 40? 20 times 2. 20 times 2 is 40, and I still need my d right there. And notice, if you would distribute this back in, you would get exactly what you started with. Same thing here. If you factored a 20 on this side, they're going to want you to factor out a 20 on that side. And by the way, 20 times 5 is 100. That's all they're wanting you to do right there. Just kind of a strange little problem. I do want to take time to do number 8. Because number 8, I see a negative, and so I'm thinking, oops, we better have time to go over that. So let's look at that one. It says -5r minus 15t equals -20. Okay. Anytime this first term is negative, you're going to want to factor out a negative. So no matter what, I know I'm going to pull out a negative. Now look at all these numbers. I have a 5, a 15, and a 20. What's the greatest thing that will go into all 3 of those terms? Well, it'd be a 5. So I'm going to do this. -5, and I'm going to look for something here so that when I distribute this -5 in, I get exactly what I started with. Well, -5 times r would give me a -5r. Here's where things get really kind of crazy. I know that 5 times 3 is 15. And I know I need a t, but what's the sign that I need in there? Well, it needs to be negative, and a negative times a positive is going to give me that negative. And remember when I said earlier that anytime you have a negative out front, how it changes the signs of everything inside? Do you see how that was a negative and now it's a positive? Do you see how this was a negative and now it's a positive? Okay, that's what happens when you pull out a negative. Well, again, if you factored out a -5 on the left, make sure you factor out a -5 on the right. And -5 times 4 is what would give you -20. So that's what they're wanting you to do right there. All right, let me see if I can find another one. I think I'm going to go back and do number 10. Is that the one I wanted to do on 4D? So I'm going to get a clean piece of paper. One moment. Okay, this is 4D number 10. And I just kind of went through the book and I was kind of looking at a few that I thought, maybe this one might give people grief. So I'm trying to find some. That's number 10. And they say to divide by the greatest common factor and solve for the unknown. Then they want you to solve for this Q, this variable. Now you can do it by factoring out the greatest common factor. I am not a fan of that, and neither is Miss Jania Carson. I say solve it like you already know how to solve it. So look what we're going to do. I'm going to pretend we have this imaginary wall here. And notice I've got Q's on the right and I got Q's on the left of my wall, and they want to get on the same side of the wall. So what I'm going to do is I'm going to take this guy and I'm going to move him to the other side of the wall. Notice this isn't just any old 5Q, it's a minus 5Q. So in order to take him and throw him over here on the other side of the wall, I've got to do the opposite. What's the opposite of subtracting 5Q? Adding 5Q. So if I do it on the right side of the wall, or the right side of the equal sign, I got to do it over here on this side of the wall. So I'm going to add 5Q on this side. All right, so what do we got? 7Q plus 5Q is what? 12Q minus 15. Notice my equal signs. I'm kind of trying to keep them lined up. These are gone. So I just have a boring little 9 over here on this side. So I'm looking, remember your variable? You want to get this guy all by himself? So I need to get this minus 15. I'm going to pick him up and I'm going to throw him over the wall. How do you throw him over the wall? What's the opposite of subtracting 15? Adding 15. That's right. Trying to give you guys time to think just a little bit on your own there. Again, you got to do it on both sides of the wall. You have to keep this balanced. These cancel. Negative 15 plus 15, that's 0. That's gone. So all you have on the left side is a 12Q. And 9 plus 15 is what, 24? So this says 12 times Q. What's the opposite of timesing by 12? Yep, you're right. Dividing by 12. So these are going to cancel. 12 over 12 is 1. So I have a 1Q. 24 divided by 12 is 2. So that's my answer, Q equals 12. Now Olivia's been a really good helper, but we're going to do one more, Olivia. We're going to look at number 14, and we'll use pink just to make Olivia happy. And this is what we've got on number 14. Whoops, I just put that decimal in the wrong spot. That's a 0.34. There, that looks all nice and neat. All right. You could do this with the decimals, but I think what they really want you to do here is get used to getting rid of decimals because they're easier to work with. So notice this is 0.34. In order to make this a whole number, I would have to move my decimal 2 places over there just to make it a nice pretty 34. If you're going to move this decimal 2 places, you have to move all the decimals 2 places, all of them. So Olivia, go ahead over here. Are we focused, and is it nice and... I'm going to take this. Notice if I moved it 1 place, it'd be a 3. So if I move it 2 places, it becomes a 30. X. Same thing here. If I move it 1, it becomes a 12. But you have to move it 2. Since you move this one 2, you have to move this one 2. So if I move it 1, it's going to be a 12. If I move it 2, it becomes a 120. So then let's just solve it like we always know how to do. Here's my imaginary wall. You're going to want to get this guy all by himself. You're going to take this minus 120 and you're going to throw him on the other side of the wall. Remember how you throw things around? This is one thing. You can just throw things all over the place, but just make sure you do the opposite. What's the opposite of subtracting 120? Adding 120. So I'm going to add 120 to both sides. So we've got what here? 30x on this side of the wall. 34 plus 120 is 154. I'm going to move this up just a little bit. Allison, you're wiggling me. Divide both sides by 30. Whatever's in front of the x, that's what you're going to divide by. So we're going to get x equals 154 over 30. Now I can guarantee you that that's going to simplify. One, I know it's going to simplify because they're both even. So you can either use your calculator to simplify this. If you simplify it, you're going to get 77 over 15, which is great. I love that answer. I would just probably leave it at that. So there you go. And that'll probably be enough for today. Olivia, if you want to hit stop.